loud, and like, I know nobody else cares what my voice sounds like.
Jordan
but
was
I'm
plan
like,
B
that's
for
not
today.
Me. Who is that?
Who's that imposter?
Yeah.
Good morning, everybody, and welcome to Ellensburg, Washington, USA. I think you are hearing two voices right now, both
it's so weird
me,
to,
Nick
like, if I take a
Zentner,
sellie and I'm like,
and our
okay, yeah, that's what I
speaker,
look like, and then I'll
Kellie
flip
Wall.
it so that's actual view.
I'm giving you her
Okay, thank
title
you.
slide at the
It's
moment.
Like, is that what I
We
look
are
like?
talking about the Goat Rocks Volcano today.
Yeah, no, it is.
There's
very
Hannah
jarring.
Shamloo and Kellie Wall. Can I get a report from you, please?
It
Are
was
we
really
5 by
good.
5
Yeah,
with
five
both
places
me
were great.
and Kellie?
I got Pad CU. That's always my go-to.
Not the
Tofu.
Wonder Boy is here, working overtime.
No, I eat a lot of meat because Tommy likes it.
Okay, but you would prefer.
I like meat.
Two
but
voices
I
are
think
both
for
5 by 5.
environmental reasons and animal welfare and stuff, I'd prefer to eat
That's
less.
so great. Thank you.
So we try
Thank you so much.
to get good quality stuff.
Okay, good.
From the farmers market and stuff.
Between Fiona and our friend Matt, I'm saying like all of that, like what you said about the
Hey,
Good news. They can
Yep.
hear you great.
Okay.
They can hear me great.
sweet.
Super awkward moment right now. Can you guys not talk for like 5 minutes while I talk to these guys
Yes,
directly?
absolutely. Yep.
This will give you a break. Hannah. and then you can go back to
Okay,
talking. But
that's perfect.
Give me
Yep.
5 minutes. Thank you. Okay, we're always trying new things here. So we wanted to test, since Nat the Wonder Boy is here, we wanted to test Kellie's mic and my mic right away since Nat is here. And you heard me ask them to clam it up so I could talk directly to you guys for about 5 minutes. Who can I say hi to? It looks like we're 5 by 5, so can I say hi to a few of you home viewers? We'll turn the camera around. We will allow Hannah to start. She's using hand signals right now. Hannah? You're just so, it's
My
her.
fault.
Where are you viewing from today? Vindman's Bakery is somewhere. Maybe he's in the room. Yeah, he is. Hey, Jeff. Garrett, the Dutch Knot Isle from the Netherlands. More locations, please. Torrance, California. Dayton, Ohio. Tucson, Arizona. Cinnamon Roll, Arizona. Port Wing, Wisconsin. Forest Grove, Oregon. CVO, let's go, says Mailman 458. Must be a co-worker. Half Moon Bay, California. Vinny's in Spokane. Southern Illinois. Yorkshire, UK. Trim, Ireland. Hello, Michael and Nee and others. Hannah Shamloo is very tiny. Ain't that the truth? Tempe, Arizona. Post Falls, Idaho. Alberta Gary. Snowy Pittsburgh, Pennsylvania. Frozen, Kentucky. Hamburg, Germany, Kirk and Philomath, Oregon, Lyle, Washington, downtown Seattle, Quebec, Canada, hello, bonjour, Colville, Washington, Dorset, UK, Vienna, Austria, Latha, Idaho, North Portland. Wonderful. So I want to give these guys a chance to visit some more. You'll hear both me and Kellie, and I suppose a little bit of Hannah as well. Thank you so much for joining us, and a special thanks to the anonymous viewer from Wisconsin who called Vindman's Bakery and asked, can I provide, the anonymous caller said, can I pay for a whole round of pastries and pizza slices and everything for everybody in the department. So we have been enjoying your generosity. Thank you so much. Okay.
Are we
Please.
good? All right.
Please.
It's so nice to hear
Resume.
people tuning in from all over.
Okay.
It's so
Thank
cool.
you for your help, Matt.
Yeah, it's really awesome.
If you're watching this in replay, we will start in 8 minutes.
Cool. I'm trying to see who's in the crowd. Is that John in the back there?
I'm looking for John, but
Yeah. I don't think that's him. Yeah.
he tends to come like right at the
Right on time.
yeah.
Yeah. It is. I feel good. I'm excited to talk with everybody about this stuff. Yay.
Now, was like your basalt story that you're about to publish, was that chapter 1 or 4?
That was my chapter 3. So yeah, chapter 1 was kind of the first go of the dating and some compositions. Chapter 2 was the rest of the dating and couple compositions. Chapter 3 was my basalt geochemistry
All the
and
through
isotopes.
You're a natural
The whole
performer.
timeline,
You should do
yeah.
something. I should give you
And
this
then
mic.
the last
Jordan.
chapter was focusing on the andesites and
What's this mic?
andesites and
I'll immediately
rhyolites
crack under
again, and
pressure.
how they
You
came
can
to
thank
be.
Connor
There's
for his
Still
generosity.
so much to learn. So
Did Hannah do that or did you
Yeah,
say
Hannah did. No, I didn't register the
Zircons,
name
that's so
Connor
great,
with
yeah.
whatever that amount was.
JK on the
Yeah.
book stuff.
Thank you, Connor.
oh, the
Thank you.
isotopes.
Connor?
Yeah,
Connor?
Yeah.
I still do. Oh, there's
At some point in the future, I think it would be fun to explore.
think we
But
should.
yeah, we can only focus on so much at a
and
time.
bring Joe in and for like
Yeah, yeah. Even informally, even just this next summer or the following summer, see what we find.
Show the Vindmans, it's gone, man.
so usually so who gives like
It's gone.
for you to talk to so like for the department and then it's you.
All right.
So you're like, when am I going?
I'll get the cue. Yeah, I'll just hang out up here, I guess.
Yeah.
Until it's time.
Yeah.
Great.
Yeah, so when I was at Washington State, we were in, I don't know if it's a room where the seminars typically happen, but there were so many different buildings I went to that day. Like, is that right that you guys aren't like concentrated in the same?
At Wazoo,
Yeah.
most things happen
I
in
got
the
a hot mic
Webster
on, I'm
building,
opening
the
it.
tall building, the tall, ugliest building on campus.
I don't think I did yet.
Sorry,
No.
Cougs who are tuning in.
Okay. Thank you. Okay, man.
You
Thanks.
know what's funny about that is
I put a photo
when they were building it, there
of
was
this
plans
scheduled live
to
stream. I was looking
brick
for a
the whole
photo from
outside,
Goat
and then
Rocks, and
they
the only
ran
one I
out of
could
money.
find is
So that's
you
why
and
it's very
Daryl up
concrete,
there.
is because it's actually
Climbing,
unfinished.
and my knees were so bad that day, and trying to get up there.
Maybe this was a different
So-
building.
You made it all the way and
Oh
back.
my God!
See the
I'm glad I got a chance to get in there, though. Thank you.
side of the building. I don't know
So
if
you're
I'm
going to be
saying
involved with her.
Yeah.
Maybe both of them if they can get this funding.
Yeah, I just kind of introduced her to the area. She can run with it.
Oh, I don't know exactly what you're talking about, but yeah, probably. Well, yeah, maybe. But yeah, there's like this underground sort of tunnel to go to
Yes, you did.
the seminar room
Hello.
across the way.
Hi, Barbara.
That's where I gave some of my
Yeah,
How are
it's
you?
a big room.
Good.
Oh, there's actually, yeah, there's the big one, and then there's a couple
You
others.
guys made it in.
It's been a long time since I've been there. Oh, I'm glad you got to go.
Yeah, they're pretty handy, aren't they? Yeah, thanks.
Yeah, you mean the
Thank you
super.
for your
Yeah.
willingness to entertain all sorts of options.
Yeah.
I'm happy with what we ended up with.
Yeah, I was talking with one of the students, Black
You
Sweat.
can't deny them.
Bryce,
They would be
that's right.
angry.
He was
I got-
talking about his X-ray
Yeah, me too.
fluorescence
I think she was.
work, and I
Okay,
suggested
thanks.
if he had the opportunity to go to Wazoo and get some experience.
Should
What
I
does
give
it
you a
look like
public
prepping
shout out
samples?
for all of your
totally should.
heroic
It's so
activity
fun.
yesterday to get heat in the building?
He said that there's a master's student who might be going to do some work, so
You saw
tag
that.
along. Why not?
Just being in that lab is so much fun. At CSUN, where I went as an undergrad, we had our own little stuff, a prep lab that allowed us to make those great experiments.
Yeah.
So I actually used
Thank you, Rachel.
You did too. It's so much fun.
Thank you.
to nice.
So do I. Same to you.
Yeah.
Same to you.
Okay, I
Thank
think
you.
my phone's on silent.
Well,
Hopefully
I'm glad
no
we
awkward
recorded
moments.
that. I'm going to put that
I
on
just
a
got
loop.
this phone.
I'm hot mic right now.
I just got this last month, and I haven't fully gotten to know it yet. So
Were you able to share the link with?
no, but I'll share the recording after. That'll be fine.
We have 400 live viewers. Can I check in with you? Are we 5 by 5, please?
Yeah. I think it's nice to
Delay in the comments.
look at my audience first and see who's here instead of just like
5 by 5
coming in
both?
cold.
I know you're like sub. It's always a good energy.
Question mark?
Yeah. Yeah, people seem excited. It's great.
Thank you, Garrett.
John's excited.
Thank you.
John's
Thank you.
excited
Thank
about
you.
everything.
We need that.
Good energy.
We're good. We got 3 minutes. I mean, sometimes it's kind of a challenge up here, isn't it, to like make small talk with people that you don't know very well?
It's easy to talk to.
Yeah, she is. Talking about the future.
We got big plans.
Yeah. Yeah, I'm excited to talk more with you about that. What ideas you have. I love the videos. The Nick on the Rocks videos are so great. The Mount Baker one that just came out, so cool.
Thank you.
Like even, you know,
For our work.
for us
Yeah,
too.
like as a parallel between
those-
Baker and Goat Rocks.
Yeah, I was looking at those, I guess, drone shots of
Oh
that
yeah,
skylight there.
that
and
kid
I'm
is
like,
good.
Hello, it's
Yes.
just like the Devil's Horn skylight, which I'll mention briefly today.
Good.
So yeah, super exciting.
It's so cool.
Well, I guess we need to do a Nick on the Rocks from the Goat Rocks then.
That would be amazing.
Yeah, it might be logistically challenging to get
know.
the camera equipment in there, but we can do it.
This kid puts everything in one backpack.
Yeah.
He's got a mini drone, he's got mics, he's got cameras. So that's what I was hoping for. We just put one up last night that's all backcountry up in the Yellow Aster Butte area north of Baker. So it is
Problem
doable.
It's wilderness.
Well, we got
So-
backcountry Gary though, who has got connected with the Forest Service and other things.
And
We've
those
had,
drones can be okay.
yeah. Well, we had to have a Forest Service person babysit us.
Yeah, you have to get the right permit, but okay.
Anyway, something to think about.
Possibilities.
It's encouraging, right?
It is. That's exciting. Oh my gosh, that would be so helpful for some of these areas that you can't walk to.
Especially the Devil's Horns, right?
What's going on?
There you
yeah,
are, guys.
Yeah, and there's
front and center.
other valleys
As always, as we
in
should
the
be.
sort of Klickitat
You ready for
divide
this?
that I'm sure
Good.
are similar. And
If
we
you're in
kind of
the
walked
back,
up to
it
the
just
edge,
doesn't
and
work.
it's like steep face, and the only
too.
way to get to that would be
too.
either rappelling down or
Thank you for setting
drone.
the tone here.
Yeah.
Hey, free food. I mean,
That would be great to chat him. Oh, I should watch the recording if it's available. Yeah. Sweet. I might move around a bit, and if I come up here, am I going to be Nick? I guess will adjust the camera. Okay, because if my voice starts waning, I might need to be closer. So. He's gonna be having to track me. I'll be like nervously walking all over the room.
I'm like, Kelly, dude, just leave. I love it.
Gotta keep him busy.
Okay, I think we're ready.
Thank you.
Okay, I'll do a quick intro and we'll turn it over to you, Kelly. Good afternoon, everybody, and welcome. Thank you so much. Such great energy in the room here today on this wintry Friday afternoon. Thank you for getting us onto your schedule. This is a Friday noon talk, and we have a very special guest who spent 8 hours driving from Portland, Oregon to Ellensburg, Washington yesterday. Can we give Kelly a round of applause?
Thank you. It was quite the journey.
That's a 3.5 hour drive normally. It took twice as long plus. Okay, so that's an extra reason to appreciate our guest. I have a couple quick announcements talking about the future talks in this series this winter, and then we'll turn it over to our speaker. Thanks to Vindman's Bakery for supplying beautiful treats. And that's an anonymous viewer from Wisconsin who phoned the bakery and asked if they could treat us all. So that anonymous person in Wisconsin is responsible for that effort today. Wonderful. Bree, you need to see Bree McGinnis in the back if you haven't done any paperwork about permission or lack thereof to get your face on camera if you prefer. If you haven't seen Bree about filming, please do that on the way out today. Otherwise, you're good for the rest of the school year. We are entertaining at 4:30, Hannah? 4:30. 4:30 at Cornerstone Pizza. You are welcome to come and join us. Our speaker will still be in town. You're not leaving already, are you? You just got here. Okay. So get a chance to visit with Kelly, Hannah, some of the rest of us, if you like. Cornerstone Pizza down by Safeway. 4:30. We'll reserve a big table, and you are welcome to join us then. I'm stalling. It feels like there's something else I wanted to say. Is there anything I wanted to say? No. So, if you come back next week, we have a talk next week. Professor Susan Kaspari from our department is giving a talk next Friday, January 26th, My Year as a Fulbright Scholar in Norway, exploring dust deposition on Svalbard glaciers and advancing sustainability in teaching. That's next Friday. We'll see you then. February 9th, Marie Takoch will be speaking. She is up on the 3rd floor in the Instrument Tech Lab. To mix or not to mix, details and timing of a magma storage, recharge, and eruption at Misty Volcano, Peru. That's her PhD that she's wrapping up from Oregon State University. And finally, Friday, March 1st, we will have a guest from Spokane, Anthony Schoen. Susan hooked us up with him. Anthony will talk on electrifying CWU's heating system with geothermal energy. That is the language and literature thing, right? He's involved in that project of taking language and the L&L building is going down. You've seen it all fenced off already. There's a new geothermal system being put in. I don't know what I'm talking about now, but this guy's involved. Come on March 1st so that you can check that out. Our speaker today is Kellie Wall. Dr. Kellie Wall grew up in Port Orchard, Washington. She got a bachelor's at Washington State University, that's Pullman, Washington. She got a PhD in geology from Oregon State University in Corvallis. Her mentor there, one of her mentors, Anita Grunder. And now, Kellie is a postdoctorate fellow at the Cascade Volcano Observatory, USGS, in the Portland area, Vancouver, Washington. Kellie's talk today is on the Goat Rocks Volcanic Complex. I'm sure that you will enjoy this talk. I'll get the title slide up as soon as I get back to my chair. Please help me welcome Kellie Wall.
Oh, thank you. Thank you so much for having me. It's so great to be here. I will say the welcome has been very warm, even if the weather is not right now. And I'm really delighted to be here to talk about this Goat Rocks Volcanic Complex, this cluster of volcanoes that is nearly in your backyard here in Ellensburg. And it's sort of, I think of it as sort of like our own local Three Sisters volcanic complex, except that it was active over a much longer period, about 3 million years. So in this talk, I'll go over kind of the state of our knowledge of what we know about this system and its history. And then hopefully by the end, I'll leave you with some curiosity about how much more there still is to learn about this awesome area. And before we dive in, I just want to take a moment to acknowledge and thank several collaborators and funding sources, which I've shown on the slide here, particularly my PhD advisor, Anita Grunder at Oregon State University, the National Science Foundation, who funded a lot of this research, and also my graduate research fellowship, several other great organizations that helped fund this work, and so many collaborators and field assistants without whom this work would not have been possible. So thanks to everybody.
Kellie, I remembered what I wanted to say. You're just getting started here.
Go for it.
Kellie is soft-spoken. If you're having a hard time hearing her, please, there's empty chairs right in the front. Now is the time. Come up early, and Kellie's going to try to speak a little louder, but we don't have a mic system in the room. That's what I wanted to say.
Please
okay,
feel free
Kellie,
to move up if you
we're
need
ready.
to, and I'll move around a bit. Is this okay if I stand up here?
Totally.
Okay, great. Yeah, so let's move on to the next slide.
Excellent. Thank you.
All right, so in the title slide, I use this term andesite factory. What am I talking about here? Well, I'm sure you all are familiar with our beloved local peaks like Mount St. Helens, Mount Hood, Mount Rainier, these major composite volcanoes that were built up by eruptions of mostly andesitic to dacitic lavas and tephras over time, over and over again. So these themselves are like these factories for andesite magmagenesis. And if we think even on a bigger scale, there are places where these types of volcanoes may be built up over and over again or in clusters. And so why do we have these locations that are almost like hotspots for andesite magmatism? They tend to form along subduction zones like we have here in the western North America. And so again, these are focused sites of andesitic to dacitic magmatism. And we're going to be focusing on this area, Goat Rocks, where several of these composite volcanoes were built up over and over again through time. All right, animation is done. So, Goat Rocks. It's located here approximately between Mount Rainier and Mount Adams in the central southern Washington Cascades. And it is named for the abundance of mountain goats that poke around on the peaks. Essentially, it comprises the Goat Rocks Wilderness Area, which maybe some of you have explored. If you've hiked through the PCT or day hiked up to Goat Lake area, that's in this amazing volcanic landscape. This map on the right is modified from a great map that Wes Hildreth put together in his 2007 volume about the Cascades. And I'm just highlighting Goat Rocks here in this kind of pinkish oval. It shows that there are several vents that comprise this volcanic complex. And time has been our friend in revealing the history of the Goat Rocks complex. Over time, glacial erosion, weathering in general, has worn down what may have once been mighty peaks like nearby Mount Adams or Mount Rainier into now a series of ridges. And there are some places where you can walk a trail up to the bottom layer of the volcanic stratigraphy and look at the first eruption that came out of a volcano. So we're looking at like the birth story of these major volcanic systems. And I just think that's so amazing. It's a record that we don't really have at most younger active volcanoes because they're constantly erupting more material and burying their older history in the younger deposits. So at Goat Rocks, we get to look deeper in time at how these types of systems evolve. Before I started this work, there had been several geologists who had done really amazing detailed mapping work through most of the area. Clayton, Swanson, Hammond, Gussie, and others have worked in this area and done really awesome work. And that really laid the foundation for my own project, where I was able to come in and use this as my map to find what units to target for my geochemistry work and such. And so really then I was just kind of ground truthing that work that had already been done and providing any updates that became apparent from my own work. So a lot of mapping had been done, some measurements of paleomagnetic directions of the rocks. So basically, when a lava flow cools, it records the orientation of the Earth's magnetic field. And we can use that as a relative time indicator. So a lot of information about that was known for some units. Some dating had been done. Maybe on the order of a dozen ages had been determined for this area. And on this timeline at the bottom here, I'm showing the handful of ages that agree well with my new data. So at this time, really not a lot of information was known about the timing of things at this system. So that's kind of where my work comes in. So we did some field work over several seasons, and I just wanted to throw up some beautiful pictures of this area. It's just incredibly scenic. We had some bad weather days too, of course, but we tried to plan for the best time of year, which typically was August into September. Wildflowers are beautiful, most of the bugs are gone. And we weren't there for entire summers. We would go out for periods of several days. I think the longest trip I did was 10 days. And that's because this area is pretty remote and rugged. There are some areas you can drive up to and get close, but for a lot of this work, we were hiking in 5 to 6 miles, setting up a base camp and working outward from there. And then after several days, we had almost too many rocks to carry, so we had to get out of there. So we kind of pieced together the work over multiple short sessions like this and put together a really nice collection of samples. So ultimately in this work, I was trying to piece together this sort of 4D model of what was happening where and when. And so that was built off of the field mapping and sampling campaign. We did some geochronology and paleomag work, and then a lot of geochemistry. So there had been a lot of major element data for some units, some trace element data, but this work contributes a lot more trace element data, some isotope data, and then some mineral compositions. So I'll go over some of those things later. So one of the principles that we use for dating rocks is radioactive decay of unstable isotopes into more stable daughter isotopes. And one example of that is 40 potassium decaying into 40 argon. And we use the technique of argon dating to date these rocks. So in this animation here, the potassium 40 isotope is basically like the blue, and over time it decays into 40 argon. And that rate of decay is pretty regular. And so we can measure basically the amount of that isotope that has built up in a sample to determine how old it is. So I used argon dating, uranium lead dating in zircon crystals. The argon dating, I should mention, we mostly did on ground mass. So basically the remaining liquid part of the magma or lava that flowed on the surface. When that cools, it develops little microcrystals, and those crystals locked in the isotopes at that time. So ultimately contributing new ages for 39 samples. So basically quadrupling the amount of age data that we had before. I just wanted to show an example of what the argon age data looks like. So some of you may be familiar with this from your geochronology classes. This is a plateau diagram. So our samples for argon dating are irradiated in a nuclear reactor, and that converts additional potassium to argon so that we can measure everything in one analytical session. So we're just looking at argon isotopes. And so those samples, they're gradually heated in steps by a laser at higher and higher temperatures. And eventually, the data that comes out converges at a similar age. And so we call that a plateau. Where it forms a plateau, we select those steps and calculate a weighted mean age. So for example, this sample from County Line Ridge has an age of about 2 million years. So taking all of that age information, putting it together, now we have this updated eruptive timeline. And so I'll walk you through what's going on here, because there's a lot of data here, but just the overview. I have stacked the timelines of the regional mafic volcanoes that are around the Goat Rocks complex. Those are on the bottom in the warmer colors. And then above that is the timeline for the Goat Rocks Volcanic Complex itself in the cooler colors. And each of them within are stacked either by oldest to youngest or in stratigraphic order where we have that information. On the top, you see those bars. Those delineate the lifespan of a single volcano in the complex. So for example, let's see, I'll use my pointer here. Here is the age range for Tieton Peak. That's determined by these ages here. So that volcano was active between around 3.1 million years ago and about 2.6. So let me just highlight for you kind of the main points to take away from this. In total, the Goat Rocks Volcanic Complex comprises 3 million years of activity. So from 3.1 million years ago to about 100,000 years ago, we had andesitic volcanism continuing to erupt in this area. The first of these volcanoes was Tieton Peak, shown in the picture here, and it erupted at the same time as this nearby mafic volcano, Devil's Wash Basin, on top of this Devil's Horns rhyolite deposit, which we still have a lot to learn about, and some of Hannah's students are working on that right now. But the timing between that rhyolite deposit and this first andesite volcano is only 100,000 years, which is still a big number, but in the grand scheme of this system's history, that's pretty close in time. Following that, there are a couple of outcrops where I dated samples, and they yield ages on the order of 2 to 2.3 million years. And we actually don't know where these lavas erupted from. They may represent the younger end of Tieton Peak, or maybe they erupted from another volcano in the area that's been so eroded away that we don't know where it is anymore. So that's kind of an interesting mystery. Following that, the Bear Creek Mountain volcano emerged. And this is a really cool one I'll touch on again in a minute. But it erupted these super long lava flows called the Titan andesites. This volcano was active between roughly 1.6 million years ago and about 1 million years ago. And it overlaps with the beginning of the Lake Creek volcano. So we actually had 2 of these major composite volcanoes active at about the same time. And then the Sispus Pass volcano formed during that window too. And then that was shortly followed by the emergence of Old Snowy Mountain. So during this time, we have about 1.5 million years of continuing eruption, continuing formation of these major andesitic, dacitic volcanoes. So now I just want to walk you through the map view to see what was happening where and when. In this earliest stage, actually the first things to erupt were the Miriam Creek volcano, this mostly mafic volcano towards the north. And then the Devil's Horns rhyolite erupted, which may have come from a caldera. We still don't know. There's more work that needs to be done there to determine exactly what that eruption was like. But on top of that deposit, then the Titan Peak volcano and Devil's Wash Basin emerged. Then here's Bear Creek Mountain, which I mentioned is this really amazing volcano that produced the Titan andesite lava flows. And my colleague, Daryl Gussie and John Lasher, who's here, and Paul Hammond worked on this project and determined that the oldest and longest lava flow traveled 74 kilometers from Goat Rocks almost all the way to Yakima. And that's among the longest andesite lava flows that are known in the world. So this really incredibly productive volcano during this time. Also during that time, there are some mafic units that are spatially associated with the Titan andesite flows, but we still don't know exactly where they came from. Based on their compositions, they may have come from the Miriam Creek, Hogback Mountain area, but that's still a mystery as well. Here's the Lake Creek stage where we have Lake Creek volcano and Sispus Pass volcano coexisting. And then to the north, the Hogback Mountain Shield Complex emerged on top of that Miriam Creek volcano. So this is a site where we have mostly basaltic volcanism occurring over and over again through time, adjacent to the Goat Rock Center where we have mostly more evolved compositions erupting. So that's kind of interesting, these 2 parallels of recurrent activity. Finally, this is the Old Snowy Mountain stage where the dominant vent was at Old Snowy Mountain. We have several other volcanoes in the area like Goat Ridge and Coyote Lake. And then to the south, there were these mafic volcanoes, Walloped Lake, Coleman Weed Patch area, and Lakeview Mountain. I also want to point out that towards the north of this area, near White Pass, there are also some young andesitic and dacitic volcanoes that emerged. One of them is Spiral Butte, which forms this beautiful cone you can see from Highway 12 if you're ever driving through that way. Its compositions are similar to some of the other younger Goat Rocks compositions. So there's potentially a question to be explored of what's the relationship between Goat Rocks and those young White Pass volcanics. And that wasn't really in the scope of my work. I defined the Goat Rocks complex based on the locations of the mafic volcanoes that surround it and sort of defined this shadow zone beyond which the mafic eruptions could come up around. So won't go into all those details, but for now we're just going to focus on what I call the Goat Rocks Volcanic Complex. So now that we have that time piece, we can start to explore what changes may have happened through time and what were the magma compositions. And I love this cartoon that's shown on the right here from a paper by Kathy Cashman and others. Just a really classic figure that shows what's happening between the Earth's mantle, these magmas coming up through the crust and how they're filtered, and some are stalled at the lower crust and some differentiate and travel up farther, creating this transcrustal magma mush system. So we're going to try to explore what's going on down there through time now that we have that framework. So I did some compositional analysis, including major and trace element concentrations. some radiogenic isotope ratios for key samples, and then some mineral compositions as well. And the photos here show, on the left, this is a backscatter electron image of an amphibole crystal, and you can see it has that really nice cleavage angle shown in this micro scale picture. That crystal is about 1 millimeter across, so we're really zoomed in here. And then on the right, that's me melting rock powders at Washington State University to produce these glass discs that are measured for X-ray fluorescence. And basically, you get to make lava when you're doing this, so it's super fun. Highly recommend. So here is the broad overview of all the compositions that we've analyzed from this center over time. And there's way too much to take in right now, but I just want to have you draw your eye to the broad range of compositions that are represented here. The peripheral mafic volcanoes are shown in the warmer colors again, so mostly ranging from basalt to basaltic andesite. And then the Goat Rocks Volcanic Complex ranges from andesite all the way to rhyolite. And this on the right just shows a map of where all these samples were taken from. So we tried to cover as much ground as we could to get a good sense of what was happening through time. Now, considering that timepiece, it's really interesting the different suites that we have. So early on, I'm just going to animate this figure for you. We have quite a range of compositions from andesites to rhyolites. Then the compositions really converge into a narrow range of andesite compositions. Following that, the Lake Creek stage has a little bit more felsic representation, and then in the last stage, Old Snowy Mountain stage, we again have everything from andesite to rhyolite, but shifted downwards towards lower potassium on this plot. Even within the middle stages of Lake Creek and Bear Creek Mountain time, we have this transition from a little bit less silicic to a little bit more silicic. So that's this diagram here. The arrow shows this progression towards higher silica through time. There's also textural changes that I think are really fascinating. The images on the right are pictures of thin sections. On the left side are plane polarized light, and on the right side are cross polarized light. And all those little like blocky shapes are crystals in those lavas. These are all shown at the same scale. And I hope you can see from these pictures that the top two have really coarse crystal textures. They have a lot of big crystals in them. And then the younger stages at the bottom tend to have fewer and smaller crystals. So there are definitely some changes going on through time that will be interesting to explore. Here's just an example of some of the trace element data. Again, just too much to go over now, but I want to draw your eye to two main differences. One example is looking at the greenish triangles, the oldest dacites and rhyolites, comparing those to the blue circles that are lower down on those plots, and just how different those are. There's quite a range between them, so definitely hinting at some different processes that are contributing to the formation of these magmas. So let's think about what those potential causes could be. I want to break it into two main ideas. One, are we getting a change in the supply from the Earth's mantle that's feeding this area? So is it driven by sort of the faucet below? Or are we seeing changes in the crustal processes through time? So changes within that magmatic system, the interaction with the crust that's already there. So we'll kind of break those two things apart. And I'm going to talk first and a bit more about this mafic story, because that's what I've been most interested in lately. So I call it the mafic underpinnings. It's like the foundation of this andesitic system is what were those basalts that were coming in from the mantle below. And in this andesitic complex, we don't have any basalts erupting out the summits of these composite volcanoes. So what's coming up from below is hidden to us. It's been modified by the time it erupts as a different magma composition. And so our best guess is to turn to these regional mafic volcanoes that kind of line the periphery of this complex and use those to try to understand what was the ambient basaltic compositions that could have been feeding into the system over time. And you know, you're sort of taking a leap of faith there, and do those volcanoes around it represent what's underneath it? But it's kind of the best information that we have. So while we were out doing fieldwork, we sampled these regional mafic volcanoes, including Devil's Wash Basin, Hogback Mountain, Lakeview, Wallop Lake, and other mafic units in the area. Here's a peek at some of the major element data. So this is potassium over magnesium and calcium over magnesium. Again, a lot going on in these plots, but just notice the different populations that break out. So for example, on the left side, you have this QOB2 unit, these orange triangles that kind of cluster together. And then the lower Hogback Mountain unit is a little bit more potassic for its general range in magnesium. And on the right, for example, the Devil's Wash Basin suite is higher in calcium than most of the rest. So each of these different volcanoes sort of has its own personality. They all are calc-alkaline, so that's typical of subduction zones. We don't have interplate type basalts or tholeiitic basalts here. They're all generally calc-alkaline, but kind of range within that category. Some examples of trace element data. Again, just notice the different populations that break out on the left side. One way to look at this data is to construct these spider diagrams where you're organizing the data from more incompatible elements to less incompatible elements. In this case, this is a rare earth element spider diagram where we're looking just at the rare earth series from light rare earth elements on the left to heavy rare earths on the right. These data are normalized to chondrite values. So it just lets us compare sort of apples to apples. And the patterns and the shapes of these data sets can tell us something about how those magmas formed. So for example, look at the dark, let me show with my pointer here, the darkest line here, kind of shallow, almost more flat than the rest. And contrast that to the pink lines here, which are a lot steeper. And then also notice that you can have similar shapes of these patterns, like the steep pink lines are similar to these steep orange lines, even though they're offset from each other. So some clues about different processes that are affecting the mafic lavas. We did some isotope analyses for some of these units. All of them are pretty well aligned with the high Cascades array, calc-alkaline basalts and high alumino-olivine tholeiites in the area. So mostly kind of what we would expect, but still you can see that the compositions range quite a bit even within that population. So what causes this variation? When we start comparing these different data sets together, we see two main end member groups emerge. So for example, those samples that have higher strontium 8786 values tend to be higher, more enriched in light rare earth elements and higher barium over niobium ratios, which tend to be indicators of subduction processes, fluids or melts that are coming up from the subducting slab and affecting the mantle above. So the interpretation was, okay, maybe this high strontium group, which we call it that because of both high strontium concentrations and high 87-86 ratios. So that high strontium group, maybe it had a stronger subduction signature, more fluids or melts from the slab that are affecting those compositions. Maybe the low strontium group is the opposite. But so this is kind of where I left off in my PhD work. And I was kind of unsatisfied by that. I've been thinking about it a lot and trying to think about what are the actual processes affecting these two groups. So I've been playing with some mantle source modeling, basically modeling after the work done by Mullen and others in 2017, where you have a composition of the ambient mantle, And then you have a subduction component that's a mixture between some ocean crust melt, so the slab itself, the ocean crust is melting partially, and then sediment that's subducting with that slab melting as well. So if you construct a mixing line between those two subduction end members and then mix that with the ambient mantle, what does that tell you? So this is definitely a very simplistic approach to this and something that I want to work more to refine. But from what I have here, it looks like the higher strontium group, which I should have shown here on the diagram, but here on the right side, oops, let's go back. So here, these are on the side of more sediment melt in that subduction component, where the others are on the end of less sediment melt and more of an ocean crust melt component. But they actually have a similar ratio of subduction component overall. So kind of interesting that perhaps it's not actually the amount of subduction fluids that are coming up through the mantle, but different types. So taking those modeled mantle sources, then I was playing with if you batch melt those mantle compositions, what basaltic magmas can you produce? And so again, this is a very simplistic approach, but perhaps suggests some important differences. And so in these models that I did, the more depleted type mantle with a more sediment-dominated subduction component better replicates the high strontium group here. And then a more enriched mantle, perhaps like an OIB source with a more ocean crust melt component, better reproduces the lower strontium group. There also may be a role played by garnet. So the mineral garnet, which tends to be deeper in the lithospheric mantle, it likes to hold on to heavy rare earth elements when you have partial melting. So you get the steeper, let's go back to my slide here. You get the steeper pattern like this if you have garnet present where the mantle is melting. Let's go back. So perhaps this lower or the higher strontium group also has garnet present in its mantle source, whereas the other is only spinel. So some things to think about more, but we're starting to see these possible differences between two end member mantle sources. And it makes me so curious about what these sources could look like. Do we have different layers or zones in the mantle where the deeper one contributes one type and the shallower one contributes another type? Or are they sort of interspersed with each other, where maybe prior pathways of magmas and fluids coming up have altered these little channels and not others? And so if you melt within those channels, maybe you get one type, and if you melt in the other area, maybe you get the other type. So there's definitely more to be learned here, but that's kind of what I've been thinking about lately with these basaltic volcanoes. But overall, the really interesting thing is there's no pattern in space or time with these different compositions. So you have a similar range of things erupting sort of randomly across this whole area and through time, from before the Goat Rocks started erupting to after. So then can we assume that essentially that same range of compositions is what's feeding into the Goat Rocks complex? That's kind of what we're running with right now, unless proven otherwise. So potentially more work to be done there, but that's what we're going with for now. So now that we've explored the mantle side of the story, let's think about what we can learn about the magma storage and those crustal processes. So I did some mineral analyses, including zircon, amphibole, and ilmenite magnetite pairs, which can be used because their compositions can tell us about temperature and pressure information. So there's a lot more detail I could talk about, but I just am going to summarize that here for the sake of time. So here we're looking at a timeline from oldest to youngest, from about 1.2 million years ago to present. and looking at the mineral data that's recorded by some of these units. So I analyzed minerals from several samples, trying to piece together the temperature and pressure history through time. I'll point out that this is only a small portion of the Goat Rocks history. There's 2 million years before this that I don't have much information about, so there's still a lot to be learned about those earlier stages. But here in this younger stage, it looks like we have zircon minerals, which are shown by the pink symbols, recording a general decline in temperature over time. So that pink arrow kind of draws your eye that way. The magnetite-ilmenite pairs show a similar trend. Those are the black symbols, and those also show a decline through time during the Lake Creek stage. But then, by the beginning of Old Snowy Mountain stage, some of those magnetite-ilmenite pairs and also some of the amphibole data record higher temperatures, deeper pressures. So it looks like there's some sort of transition happening between the end of this Lake Creek stage and the beginning of Old Snowy Mountain. Some thoughts about the crustal environment that this magma system was built in. Could there have been different basement or wall rocks that the magmas were seeing and interacting with through time, depending on where they were stored? Are the magmas coming up and interacting with prior intrusions from earlier stages of the system? This I've kind of only preliminarily explored, but I have some clues that I want to show here, including this zircon age data set. So mostly I was focusing on trying to date the eruptions by looking at the youngest populations of zircons. But some of these samples actually carry zircon xenocrysts that have much older ages. Some of them overlap in time with earlier stages of goat rocks. So for example, this lava from Lake Creek stage has 3 million year old zircons in it, perhaps from earlier Titan Peak magmas that were stalled in the crust. There are also some that are much older than Goat Rocks and overlap in time with some of the regional basement units. Like, for example, there's one crystal, and we can only interpret so much about single data points, but this is suggesting that there could be more work to be done here to explore the relationships of these older zircons to what crustal rocks were there at that time. And also, again, earlier I mentioned these differences between the earlier Titan Peak dacites and rhyolites and the younger ones and how different those were. In this oldest stage, we have really high zirconium and other high field strength elements. Zirconium in particular is interesting because typically you have the mineral zircon start to saturate at andesitic or dacitic compositions of the magma, and that pulls out all the zirconium. So normally you see a pattern of increasing zirconium as it's incompatible, and then zircon comes online and pulls out most of that, so you have a decreasing trend here. But these earlier samples actually have quite high zirconium, and I haven't fully dived into why that could be, but my suspicion is that perhaps it represents mixing with crustal melts. So I'll go through a sort of working model for the evolution of this volcanic complex based on some of the data that I've provided and also some hypotheses and some questions we still have to answer, but sort of the working knowledge that we have. So early in the stage, we have a diversity of compositions. We have those really enriched dacites and rhyolites. Perhaps during that stage, as the magmatic flux is sort of waning and turning on, those individual batches of magma are filtering up through the crust, and some of them get stuck, and some of them induce the surrounding crustal rocks to start melting, and so you get a very diverse array of compositions. But perhaps, as you move forward in time, maybe there was an increase in the magma flux that led to the establishment of this sort of homogenization zone where melts were getting stuck in this big magma reservoir. And increasingly mixing with each other and producing a very narrow range of compositions. Following that, we have this evidence of decreasing temperature. So maybe the system was kind of shutting down as perhaps the magma flux was waning. And finally, we have evidence for deeper and hotter magmas, and perhaps that represents these magmas being able to filter up through the crust more easily because there's not that big mushy zone hanging out there. We know that, or we believe that the same range of compositions is probably feeding into this system from the mantle over time, but perhaps there's a changing flux of that, a changing volume of material being supplied. And maybe that's what contributes to this sort of thermal cycle that we appear to see. Still much to be learned. But in summary, at the Goat Rocks Volcanic Complex, we have 3 million years of volcanic activity occurring in this area over time. The later eruptive stages represent essentially a continuous 1.5 million year system where you have these composite volcanoes being built over and over again, really in short succession. Looking at the regional mafic volcanoes, we understand that there's an assortment of calc-alkaline type basalts, but no real pattern in space or time, so we assume that the same range is what's feeding into this system. And perhaps there are 2 end-member mantle sources that are feeding those. And then we're seeing evidence for different magmatic and crustal processes, and the question is, what's causing those differences? So the running hypothesis is maybe there's a change in the magmatic flux, and that's something that could be explored further. So some of my own lingering questions include, what were the magma storage conditions in those earliest stages where I don't really have information? Where were those magmas being stored? Were they deeper and then becoming shallower and shallower through time? Do we have evidence of a really distributed system from the early stage? There's so much to learn there. What's the role of crustal assimilation? What are the different crustal rocks that are being partially melted or mixed in into these magmas, and how does that affect the evolution of compositions? And then also seeing that very close time between the Devil's Horns rhyolite and the first andesite volcano of the Goat Rocks complex. What are the magmatic processes that drive the Devil's Horns, and how does that relate to the development of this Goat Rocks andesite center? Also, the mysteries of where are these vents for some of these lava flows, like the 2 million year old lavas and also the mafic lavas associated with the Titan andesite flows. Where do those come from? Maybe with more field work, we could be able to find where those vents were. That's all I have for today, and I would love to take any questions that you have. Thank you for having me.
Let's do some question and answer with Kellie. And Kellie, if you wouldn't mind repeating the question
Sure.
so that everybody, even online, can hear the question.
Yeah, totally.
Questions, please.
Thanks. I've been interested in the Titan andesite flow for a long time, intrigued by that, and I was wondering if you know what factors might have led to that being so long compared to others?
Yeah, the question is about why the Titan andesites are so long compared to these other lava flows from Goat Rocks and other similar types of volcanoes.
Thank you.
And it's a really great question. I wish that I had a solid answer, but some thoughts I have are perhaps it was hotter and so less viscous and was able to flow farther that way. Or maybe it's related to the topography that existed at that time, where you had this Titan River channel that maybe allowed it to form a lava tube, and as it crusted over, it sort of insulated it and allowed it to keep going and going. Why that happened during this time and not some of the other times where the topography was probably similar is an open question. So yeah, I'd love to see somebody really work on that. What else? Yeah.
What would be the height of these volcanic
Yeah.
time that they're kind of going off at the same time?
Oh, yeah.
Big is Mount Rainier?
Yeah, the question is about what were the size of these volcanic edifices at the time they were most active compared to now. Because now, you know, the tallest peaks in the Goat Rocks area are maybe 7,000 feet. But based on the map view of the existing deposits, the remaining deposits today, what we've done is we've looked at the distance of those lava flows and compared to the distance of lava flows at younger centers and what that relationship is to their height. And so we came out with an estimate, and this is a very rough estimate because there's a lot missing. But based on those distances, we estimate on the order of maybe Mount Hood size, maybe between Mount St. Helens and Mount Hood size. So not quite as big as Mount Rainier, but each one still a significantly sized composite volcano. Yeah.
At the beginning, you mentioned that some places that is a andesite factory, that some places
Yeah.
are producing more andesite than others. Do you have the sense, is Goat Rocks unusual compared to, like, if we were to slice down into Rainier or some of these other locations, would we still see some of the same overlapping volcanic complexes? We're just afforded this opportunity here, or is it? Do you think it's unusual compared to other volcanoes?
Yeah, so I guess what I think you're asking is why do we have this record of multiple volcanoes in the Goat Rocks area compared to, say, Mount Rainier, a single volcano?
Yeah, would we see something like that if once that gets eroded?
Yeah,
We'll
so
see the same kind of complex.
yeah, once something like Mount Rainier erodes, what would that look like today? And it's a great question. I think what's really interesting about Goat Rocks is because it represents a longer history, maybe we're seeing like the full life cycle of one of these hot spots, I say, for andesite production. And maybe some of the active volcanoes today, like Mount Rainier, Mount St. Helens, are just sort of in their earlier stages. Maybe in the future, they will continue to produce new volcanoes, or maybe a different sort of structural environments. Maybe you're more likely to get clusters of volcanoes rather than one single one. So there's multiple factors to consider. But yeah, the question of is Goat Rocks unusual for having such a long history is a valid one. Excuse me. What other questions? Yeah.
Kellie, I was really interested by what you mentioned about this difference between the amount of subducted sediment signature versus oceanic crust signature. I've been thinking about some similar things for much older stuff in Cascades.
Cool.
And I was wondering if you could consider looking at the hafnium isotope signature of the zircon, because if you have sediment signature, you might expect that to contain old detrital zircons that have really old hafnium isotope signature compared to the oceanic crust that you'd expect to be quite different.
Yeah. Okay, so the question is about thinking about this possible mixing between a ocean crust component and a sediment component, and could you look to hafnium isotopes to tell you about that process? And I do have hafnium isotope data for the samples that I analyzed isotopes on. And I have not yet been able to make sense of it because it records a really broad range of hafnium isotopes, broader than what we see at most of the rest of the high Cascades. And I'm not sure yet if that is meaningful or if there's something that went awry in the sample prep process. But it does span the range between the Simcoe volcanic field data and the high Cascades. So maybe there really is some mixing represented there. But I need to spend some more time thinking about that. So thanks for bringing that up. I'd love to talk more with you about your ideas.
One more? Well, did I just kill it? Really, that's it?
Oh, yeah.
It seems odd that it just turned off 100,000 years ago, right? To the north, you've got Rainier. To the south, you've
Yeah.
subduction zone is still going on. And my question is, do the rocks give you any hint of the late stage, 100,000-year-old andesite? Is there any hint about why it just terminated?
Yeah. So basically, the question is, why did Goat Rocks seemingly stop erupting? We assume that it's extinct. Maybe that's an open question. But does the rock record tell us that the system was shutting down, basically, compared to other active systems? What I think is really interesting there is the time piece, where as Goat Rocks is sort of in its final stages, that's when a lot of these neighboring volcanoes start to really kick up. And so is there like a regional scale relationship between the flux of magma that's provided to the arc? As far as what the rock record reveals, I think that's still something that we're trying to figure out. It's like, what is this life cycle? Do the old Snowy Mountains stage lavas, does their composition tell us that it's basically done? It's interesting because those compositions are actually similar to what we see at Mount St. Helens now, which is a very young volcano. So yeah, there's still research to be done, I think, to see what those compositions in time really represent. But yeah, is it done? Maybe an interesting question to explore. Could it ever wake back up one day? Because that time since its last eruptions is pretty short compared to its long history. And even the gaps in time, the apparent gaps that we see in the earlier stages are much longer than that time frame. So maybe we'll see something in the future, probably not, but we're keeping an eye on it.
She ended with a cliffhanger, everybody. That's great. Let's thank Kellie again, please.
Thank you.
Thanks for coming. If you want to come up and talk to Kellie one-on-one, that's great. We'll also see some of you 4:30 Cornerstone Pizza. Thanks, everybody.
Yeah, see you there. Thank you. Thanks, Nick. Oh, thank you.
You must feel good about that.
Yeah, it's so fun to share that with people.
You are a pro.
Oh, thanks.
You really are.
I'm so glad I know.
Oh, you'll watch the replay at some point of this thing, and all these wonderful comments are scrolling by. So thank you. Okay, well, I'm going to let you talk to some of these folks. Thank you. Thanks, man. Thanks again.
First started talking, I thought maybe we won't be able to hear her back here, but it was
It worked out okay? Good.
Went well.
Good. Thanks.
She has a melodious speaking voice, carries the day.
Melodious.
Hey, do you know her off the top of your head when the EHS is back in town? I don't get a Yakima paper anymore.
No,
kind of
it's
in
hard
the
to
dark.
find out, isn't it? Yeah. I'm still live streaming right now.
Oh,
You're
well,
good.
nice to see you.
You too, Jeff. Thanks. A couple final words with you before we sign off today. Thank you for tuning in to this program. Hope you enjoyed that talk. I think it's safe to say that was a strong talk. This is a series of noon lectures that we host here at Central Washington University in the Geology Department. And we have the rest of the winter quarter to go and spring quarter to go. And you are welcome to come. We have empty chairs, you notice. And I mean, it's challenging traveling today, but I'll show you the schedule one more time, and you should feel free to be here with us. We have empty chairs. You would not be out of place, and we'd all like to visit with you. And if you've been watching a bunch of the videos on this channel, you know a bunch of the geology professors anyway, so you get a chance to visit with them as well. They all know that, you know, people come in off the street and wander around the building. That's a common thing now, so it's not unusual. So you wouldn't be bursting into some sort of bubble that you'd feel uncomfortable.
Thank you, yeah. Be very careful.
I got to show you that. So we actually have undergraduates. So this is one of the benefits of what we're doing here. These are undergraduate majors. Many of them have declared their major just in the last couple of years. And they're interacting directly with professionals. And we're not the only department that does it this way, of course, but this is one of the things we're trying to do here with this series. So that, what you just saw, is not possible with Zoom talks. But it wasn't that long ago that this department said, oh, I think Zoom is so good now, I think we should just have our noon talk series and just have a bunch of Zoom talks. It won't cost us anything. It's not that. This is what needs to happen. The people need to be here, whether they drive through 8 hours worth of snow or not. Okay. So next week is this. Friday, February 9th is this. And the last Friday or the first Friday in March will be a geothermal energy talk. You're welcome to join us. You've heard me say it a number of times. Okay, everybody. Thank you so much. If you've been enjoying the Ice Age Floods A to Z live stream series, there's another one coming in less than 48 hours. Haven't started thinking about it yet, but Jerome Lessman will be with us on Sunday morning, whatever date that is. Sunday morning, January 21st at 9 a.m. Pacific. And we will go up to British Columbia with J. Harlan Bretz in the summers of 1925 and 1926, looking for lavas that erupted during the Ice Age. Thank you, I love you, and goodbye from Ellensburg, Washington, USA. I've learned all sorts of new hand gestures, Jordan. Check it out. That's my newest. Okay, here's you want me to make it rain? I'll make it rain. Then there's the old standbys.
Which ones aren't there balloons too?
There's balloons. How do I do balloons? I always forget balloons.
I feel like originally that was like thumbs up or something. Oh, bubbles.
Oh. Balloons for you, Jordan. Little baby Jay.
You can do the double.
Double gives us.
I see, okay.
Come on, Jordan.
Get with the times.
All right. Thanks, everybody. I love you. Goodbye. From Ellensburg, Washington, USA.
Too far.
Oh, Jordan?
I got it.
Oh, well, let me get out of here. A married couple doing hand gestures.
I've never met him in my life.
Jordan again.
How are things going? I do want to ask you about
What the hell?
see
You
them
you
over
worked
here.
it before.
They're on your tablet.
Oh, there's a delay.
There we go.
Hey.
Finish with a bang.
Bye, everybody. Well, that